Hey, I'm Carl. We're going to be talking about digital identifiers and verifiable credentials. We're going to talk about how you can get started immediately today, so things you can do today with verifiable credentials, and some of the potential pitfalls that you might fall into. So who here is an engineer? Hands? Raised hands? Okay. Okay, we'll be okay. We'll be okay. So that's me. I'm Carl. I am lead product designer at Disco. So we work on verifiable credentials, of course, and basically everywhere where they might connect or where we envisage they might connect. Previously, I've been working on wallets, and personal interests are very much in self-sovereign identity, owning your own data, owning your interactions, whether they're on-chain or off-chain. So what we're going to go through today are core concepts. So what are the key terms in this landscape? We're going to go through an example did document, which is one of the terms. We're going to demo creating a VC. And we're going to discuss what could be next for SAFE. So in which ways could these primitives interact with SAFEs? And what do we need to explore in the future to be able to do that? So I'm not having this discussion with answers. I'm not trying to shield Disco stuff. I'm saying, here are the primitives, and how do we think we might be able to use them in the future? So core concepts, or glossary of terms, effectively, we've got the DID, so your decentralized identifier. We've got the DID method, which is the type of identifier, kind of like your Cape 10 chain ID type thing. The DID document, which is what that identifier signals. The schema, which is specific to credentials. So, for example, I might create a membership schema, and then I want to query other people who have membership schemas or request membership schemas from them with a certain issuer. And of course, that ties into the credential, which I just spoke about, which is signed by the issuer, contains information about the recipient, contains information about the signing scheme, and a presentation, which is a presentation of that credential, so a further wrapper around that. So I'll pause there. Have I lost anybody yet? Or are we all kind of following? Okay. So the DID document is, in this example, is DID Ether. So this is posted on chain and offers certain capabilities through the DID method, or the specification effectively for DID Ether. So inside this, we can see it has a lot of different fields that do a lot of different things. But one of the key things that isn't highlighted in this is the fact that this DID document supports things like key rotation. And this DID method, DID document, has existed for quite a while now. So we've had these key rotation capabilities for a long time. But it does have some drawbacks. So, for example, you can assign a contract to be the owner or the DID, the identifier. So, for example, DID Ether contract address. However, you're gonna run into issues there. How does that contract sign a credential? How does that contract preserve somebody's privacy if it's issuing the credential to somebody? And the way that DID Ether works around this is to provide the capability to assign a delegate. So you can say, I want this address to act on my behalf. That is then posted on-chain, and then this delegate can issue valid credentials and do things like that. So it's not a perfect solution in the case of DID Ether, and it does have limitations, being that there's a gas cost associated if you want to get the benefits of this key rotation or delegation. And it requires concurrent systems to manage on-chain, off-chain. So your delegate is off-chain and you're having to manage that separately, whether you're doing some kind of MPC thing to gather signatures or whatever it is. But there are other DID methods that came after this aiming to solve kind of these problems. And DID 3 was one of these. It's one that we used at Disco. It's one that some users still hold. And it facilitates key rotation. It's a pretty powerful document. It lets you do a lot of things. However, it does come with some pretty significant UX drawbacks as a result, and security drawbacks. So because the DID 3 wants access to standard signing curves, it can't use, for example, you can't use with that EIP 712 sign type data or sign message or anything like that because of the string that's prepended to those messages. So the way it works around that is to delegate, not delegate. The standard with that is to request a user sign a message, and then that message or the hash of that message, or the signature, is used as the entropy to generate your key pair, which is a massive phishing risk. So users sign one malicious message, they lose total control of their identity. And as a result, this DID method has been deprecated now. So things are moving very, very, very quickly. And users can still access these things because they're standard. These documents are posted to IPFS, but we don't encourage that people use them now. So this was like one of the examples of trying to move around those things. DID PKH is what we're using most often now. So with DID PKH, you have a CAPE 10 chain ID here, and then your Ethereum or Tezos or Solana or whatever it is address that follows it. So from a UX perspective, it's really good. It maps to the key a user already has. It's chain agnostic. And the method is, not generative, it's static. So this DID document is fixed. You can't change it, but at the same time, it's not posted anywhere. It's just generated based on your address and the specification. And the cons of this is it still depends on wallet functionality to go ahead and sign the credentials or sign the presentations that it wants to send to other people. And you run into the issues with EIP 712, sign message, sign type data, all of those things where third parties, potentially not in the Ethereum ecosystem, then have to add that signing algorithm, for lack of a better term, to the list of algorithms that they hold. And the workaround for this that Gitcoin use with their passport, that a bunch of different projects are using at the moment is DID session. So DID session is another DID method. And DID session is a wrapper kind of around your DID PKH that grants control to your PKH. So it forms a relationship with your Ethereum identifier effectively, or your contract identifier. But these sessions are typically valid for 60 minutes. However, these sessions are also kind of, that validity period is determined when you as an engineer or a developer or website owner, whatever it is, are requesting the DID session. You can put whatever you like in there. So you could put 60 days, 60 years. And as a result, you will then have control of that person's profile as that identifier for that entire period, which is a lower phishing risk, admittedly, if the standard is 60 minutes, but it's still a phishing risk. So if I'm putting my wallet hat on here or UX and security hat on here, even though you're delegating signing, you're still losing. So there's also the problem of resolving or indexing all of these session DIDs. So you as a result, have to rely on complex resolver infrastructure to go grab the did sessions, did session 1, did session 2, did session 3, and understand how all of these map to the did PKH, okay? So here I'm talking about the very, very kind of, the core blocks of this. And from a designer perspective, I kind of argue that these blocks are detrimental to UX because of the pitfalls that they bring for security, because of the issues they bring in DevX, and the massive amount of complexity that you have to wrangle with for ultimately just a signed object. So with that in mind, I'll move away from the did document now and talk about how we can use did PKH without did session, so just using your Ethereum identifiers, and cater to that as an Ethereum community. So what we're going to do is we're going to generate this verifiable credential. So this verifiable credential has an issuer, it has an issuance date, it has information about the credential itself. So the organization is Carl's API Club. It has the schema, which is hosted somewhere. So somebody can go ahead and query for that specific schema, or for a user to present a credential with that specific schema, and then the proof, which is the verification method. So the part of this that is non-standard at the moment, but which people are using and which we're kind of hoping W3C start to work with us on, or wallets start to sign these credentials natively, is this piece. So Ethereum EIP 712 signature 2021. So that is effectively like the algorithm. And then we have the associated signature here in the proof value. So major notes, just to recap, going to sign with Ethereum wallets. We can use signed type data or signed message currently with Ethereum wallets. We'll use signed type data to provide readability. And although these proof types aren't listed in the did spec, we do know how to verify the sender of these messages as an Ethereum community. And we can verify that the credential, as a result, is legitimate. And it's not a comprehensive example, but it serves as an example of basic concepts. So if I invite you to scan this QR if you want to follow along. If you don't want to follow along, that's fine. So this gist is just a guide on how you would set this up inside a React app to go ahead and issue a credential. So if I I'll go back to that if you want to scan or if you already have done, okay? What we're thinking about is how might credentials gate access to contracts without intermediary parties? How might proofs of valid credentials gate access to contracts to preserve privacy? How might contracts be able to issue credentials without contents being leaked, for example, in event logs? And how might wallets begin to offer this signing functionality natively to improve compatibility? So again, I'm referring to that proof piece. Oh, sorry, I've missed some things here. Okay, yeah, the README. So I won't go ahead and set this up. I did time myself before doing it. It took 10 minutes. You're going to trust me on that. Oh, I hope you trust me on that. But so initially, what we do inside this is we set up the boilerplate Rainbow Kit React Next TypeScript website. We add our project ID to the connector, and we set up like the really basic. Here's a home page with a connect button, and that's pretty much it. After that, these are the packages that we need to go ahead and sign and issue a credential. So what these are, Disco schemas, is a repository of all of the schemas that we currently use inside our application and invite others to use as well. JSON schema is a way to validate the type of the credential that you're going to submit. Lodash is just for convenience, as is UUID. And then a really important one is EIP 712 types generation to generate the types based on the data that you're going to pass to the user's wallet. And if I just skip a little bit past this, to begin to sign this, first of all, we need to add a schema to the initial credential object as we're starting. So first of all, we bring in the schema, which can be from the Disco schemas repository. We have this VC object, which is the data that we're going to seed it with, and we can ignore this for now. We then pass this and just ensure that the credential schema has an ID that is the schema ID, or that URL, and that the type is this here. So once we've got that set up, we can go ahead and import our types. So the verifiable credential type, which is this, or the interface for a verifiable credential. So we have this ID, which is either it can be the recipient or the schema. We have the issuer ID, the day, expiration day, credential subject, and the proof. So because we're going to use EIP 712, we have this here, which is really important, which will contain the full kind of the types that you're passing when signing the message itself, and then the schema separately. When we're building the credential, we include the issuer, we pass in this subject, we use the schema again, and we give it a recipient. And we go ahead and start to actually kind of build out the meat of the credential now. So we include this type, verifiable credential, which is important. We include the issuer ID, which is did PKH EIP 1551, which is what I was talking about before. We give it an issuance date, and we then go ahead and populate the contents of the credential, so the important pieces of that credential. We do some other little things with the expiration date and make sure that's tidy, but this is here pretty much everything that you need to get started and create that object. Next, we go ahead and figure out how to pass this to a wallet and how to get the types for it and do all this other stuff. So this is the message that we're going to pass. We're going to pass in that VC we were just talking about, and we're going to give it this proof. So the proof is what I ran through at the very beginning, which contains this EIP, Ethereum EIP 712 signature 2021. What this will mean is that when we go ahead and pass the domain and generate the types for the credential, and then pass this to the wallet here. So we then hit the wallet, sign type data, EIP 712, and we then append, after we get the result, all of the verification information that we need. So I know that it's a lot to grok as I am kind of just talking through this, but as you go through and set this up, you can set this up in a very, very reasonable amount of time. It's a single file, or probably shouldn't be a single file, but it's something you can get up and running with very, very quickly to send credentials to your users. And then after we've got everything and we pull all of our functions together to go ahead, build and sign, that's it. We get the credential result, and we can see, if I go back, we can see an object then similar to this. And this object is owned by the recipient and can be presented by the recipient. So they can store that wherever they like. We're not opinionated about storage. Nobody's opinionated about storage with the credentials themselves. And they can keep this private. And the next questions are, okay, how do these then interact with on-chain or contracts? how can you use something like this as an input to a contract? How can you generate a ZK proof of something like this so you can use it as an input to a contract without leaking somebody's personal or leaking the information about the credential itself? So in an ideal world, we'd probably have something like this, where a contract could somehow privately issue a credential which goes on to further gate permissions to contracts. So kind of similar to Guild and what Guild were talking about before, about gating and all of those things. How can we make the user the custodian of those interactions? So how do I ensure that there's no middleman between me and what it is that I'm doing? At the same time, like, how might we be able to gate a multisig by multiple criteria? So could we generate proofs of multiple credentials to grant access to a certain piece of functionality with a contract? And how might that situation work with a safe? So working with, or trying to understand how we can use safe modules and do all of that kind of stuff to go ahead and let you kind of plug and play with credentials to get things going. And how do we, as a result, lower the barrier to Web3 onboarding? So we're working at the moment on something called DIS with an organization called District Labs. And we want to understand, okay, can we use create2 to generate an address without that address leaving the user's kind of environment or their browser? Can we then use that as the seed for account abstraction for that user? So if a user has that address, how do they then go on to issue credentials using that programmatically generated address? And in turn, what capabilities does that unlock as they go ahead and deploy that contract? So do they get key rotation capabilities? What do those key rotation capabilities look like? Do they get multi-sig functionality? Can this root user who took this interaction off-chain come together with other parties to do similar things, to seed an account in a multi-party kind of way? And in turn, kind of like, what do those capabilities look like and what tech is missing currently to make it work? And honestly, what we want to see more of is more people using data that is secured using signatures, so off-chain. They sign their data, that data is provable. We want users to be able to take their data from location A to location B without have it be revealed publicly. And we want third parties to be able to view that data only upon explicit approval. So nobody's querying it backend, nobody's set up using the graph or anything like that to go and query every contract in existence. The user is always opting to reveal their data to the third party. And what we want to try to help to achieve is help contracts, by extension safe, to explore how to use credentials for effective access control. It could be kind of the whole horse, or it could be small pieces. Like, what small pieces might this be able to unlock? And particularly wallets, how can we help wallets preserve user privacy by helping them hold and transport, or helping users to hold and transport the data about themselves without it being leaked at every interaction to third parties, other than those who, like I said, specifically request it. And yeah, that's pretty much it. I didn't go through any of the coding stuff. Maybe I had time. But yeah, I'll pause there. Does anybody have any questions? I know it was pretty, go ahead. Just to caveat before you ask anything, like, I'm giving a very kind of fast surface level run through of this stuff, and I'll try my best to answer your questions. So yeah, go ahead.
Okay, I've got a couple of questions. So if at any point you want to skip them, or go ahead.
Okay.
So first of all, when you compile or when you create the verifiable credential schema, you said that you're using the JSON schema semantic interoperability mechanism, yet you're creating a schema based on the verifiable credential data model version 1, which uses JSON linked data. So don't you lose basically semantic functionalities by doing so?
I couldn't answer that right now. No, sorry.
Okay. Second question. You said that every single time you create a DID, you register that DID document in a verifiable data registry. Isn't the DID registration supposed to be done only once, or creating long-lived identifiers instead of short-lived that are anyways?
Yeah, so I think you're talking about did session, right?
Yes.
Yeah. So did session has to be long-lived for you to be able to go ahead and resolve kind of or ensure that the user is presenting a credential that belongs to them in the future. So that at the moment, for example, is stored with Ceramic. So you post that session document to Ceramic, and then Ceramic is responsible for all of that stuff and resolving and getting into the weeds on that. So yeah, you're right. It should be a short-lived thing, but potentially not. And that's kind of the concern with that. Like the expiry period with that is set at the point that when the user is signing the message to initiate did session, and a bad actor could very easily go ahead and set that as whatever they like. I'm not sure whether there are gates on kind of the maximum period on what Ceramic side specifically. However, I think because that if there is a gate on that side of stuff, because it's then leaving the user's control, then and it's not specified inside the session method itself or the specification, then I'm not too sure how I feel about that.
Okay.
Does that answer the question?
Yeah, that does. I don't know. I don't want to take any.
No. Go ahead. Grill me.
Okay. So you said that you're not opinionated on storage, and isn't that kind of breaking the whole SSI and DID space, because this means you didn't actually implement any transports?
Why would you need that though?
Well, I mean, if you follow the self-sovereign paradigm, users actually want to store these credentials somewhere, and this is, I think, the most important part, because otherwise you would always have to create a new DID document that is, as you just said, anyways, and stored on IPFS or Ceramic over IPFS.
Yeah.
So you could instead just present a verifiable credential, for example, through DIDCOM version 2, and eliminate the need to produce a DID document every single time you want to sign in.
I mean, you're right on not needing to produce the DID document every single time. But like, when I say not opinionated about storage of the VCs themselves, I mean, like, ideal world, I imagine the user holding that data locally and presenting it at the point of request. So maybe that point of request is the transport layer. But yeah, okay. I can't get into much more specifics.
Okay, last question. So you said you want to implement SecKP functionalities, yet in your specification you have a JSON Web Token. So how do you align this with recent developments on BLS signature suites?
ENS, sorry.
BLS.
BLS.
Like BBIS Plus.
Okay, yeah. I can't speak about BLS. Evan can. The example that I ran through was the format that we had used for our account links earlier. Back about a year ago. So that is the format that I was running through there. So I didn't demonstrate anything recent there. It was very much, like I said at the very beginning, or maybe partway through, it was more about, okay, what is a broad summary of the things that you might be able to do? And I'm just trying to frame this as user signing their data that they can then go ahead and disclose anywhere, and what are the patterns for disclosure? So like did method, shapes of credentials, all of those stuff, they do matter, but I think the space is so nascent that people have to go ahead and start breaking stuff or trying new things or submitting new things and seeing what happens, basically. See who adopts it, who doesn't adopt it. And then hopefully something gains enough momentum, it works for enough people in this room or anywhere else, and then W3C, it lands in the spec, and it's available then for more people to go ahead and use outside of the Ethereum ecosystem.
Okay, can I ask one more question for you to pick your fighter?
Pick my fighter?
Yeah.
Yeah, go ahead.
DITCOM version 2 versus OpenID Connect for verifiable presentations and verifiable credentials.
I don't know enough about the OpenID one, so I'd have to say DITCOM. Okay.
Woohoo.
Thanks for the talk. When you're talking about data, is quite abstract, and the approach that you're taking is quite the opposite of how data is being handled by big tech companies. So you're bringing in full custody of the user, in full control. On the other side, the usability of the data or the utility or value that it could be created for AI or other applications that can sit on top of it is not clear how it can be done. Can users monetize that data? Is there a mechanism to put computation on that data?
So it's up to the users to disclose the data to whoever they want to, or they might, for example, have an endpoint listed in the document to publish their data publicly. So a user could monetize their data if they opt to publish it. So that's like the explicit step. They have to opt to publish it. If a third party goes ahead, issues credentials about somebody and posts them somewhere publicly that isn't in the user's control, then that's a whole other issue. But yeah, it's like you said at the beginning, it's very much about the user taking that control of that. And for example, verifiable presentations and the user being able to present a credential, like people have been working on that subject. So what does presenting a credential look like? How does that tie into current browser experiences or current wallet experiences? And what that standard specifically looks like. I don't have the links right now, but there are some of those things listed.
Yeah, thank you.
Thank you. So I have a question. So I used to be a web app developer before I got into crypto. And one of the things I hated most about Web 2 was authentication. And I love that when I'm doing smart contracts, all I have to do is like message.sender. So I see this whole like code flow that you just went through. And to me, that just like brings back flashbacks and nightmares of having to deal with sessions and authentication. So I'm just curious as a developer, what kind of capabilities do I get by going through this extra work that has kind of already been abstracted away by wallets, and especially for a smart contract-based stuff when I can code those privileges directly into the Solidity or whatever?
Yeah. So, like, you're right. There is work involved in getting this stuff set up, and I like to be totally candid. It's more work than people want at the moment. And it's one of the things that we're working on at the moment. It is how do we improve the DevX of just being able to authenticate. It's something other organizations are working on as well. And just making sure that that authentication piece is really straightforward is really important for the reasons that you're describing. But yeah, I think that's it. Does that answer the question? Okay.
Cool. So then, yeah, I guess my other question would be, what are other ways that we could use these DIDs for purely off-chain things, like data storage, if we don't want to interact with smart contracts necessarily? Like, so just if I wanted to theoretically create like a Web3 app that doesn't have smart contract components, but is about user-owned data or like
Yeah.
whatever, like decentralized social media or something like that, how would I interact with this DID protocol?
Yeah, so I imagine I'm going to think out loud here, maybe embarrass myself a little bit. Friendtech as an example. How does somebody create a profile with Friendtech? How do they choose to send messages or perhaps even data to their friends or to the people who they're connected with in that kind of situation? And in that kind of situation, you are going to be disclosing, like opting into disclosing data that you potentially or probably already have issued by other sources. So you're going to disclose, for example, let's say Ideal World, Twitter, or X has issued a credential to say that you own a specific account. And then you can use that credential in the other places to go ahead and say, yeah, this is me. And the developer, if we're talking about developer experience, doesn't need to go and query the Twitter API to go and get that person's information. So it kind of, it centralizes the data, but it centralizes the data around the user. So the user is the endpoint for this stuff.
Cool, thank you.
Is that everybody? Okay, cool. Thank you.